Now I want to focus on overlay analysis. But before we do, I want to touch on the difference between overlay query and overlay analysis. Overlay query selects overlapping features. It doesn't create any new data, just creates a selection set in the input. Overlay analysis outputs overlapping features with attributes as a brand new layer. And we can see that illustrated in the image on the right for the overlay query, in which we're looking at the intersection of floodplains and parcels. The outcome includes selected parcels that intersect the floodplain. And it doesn't matter whether the floodplain intersects a little bit of the parcel or all of the parcel, it selects the entire parcel in the outcome. And we can see that diagrammed in the image as well, in which the parcels are represented as the gray rectangles in the input, and the floodplain are the selecting features represented as the yellow circle. And in the outcome, the parcel features that intersect the selecting feature are selected. And again, it's the entire parcel, not just the portion that intersects the floodplain. In overlay analysis, we're creating a new layer with features and attributes. So in this case, we're intersecting again the parcels and the floodplains, but the output includes a whole new layer with all new geometry that represents the intersection of these two layers. So the parcel that is highlighted in the image is no longer one feature. It's now split into two features that is represented by two records in which they are coded as inside or outside the floodplain by the FID flood field. So -1 would be outside the floodplain and 3 would be inside the floodplain, and the shape area field would represent all new calculation for this new geometry. And again, we can see that diagrammed in the image below, in which the input parcels are represented by the gray rectangles, the floodplain by the yellow circle, and then the output creates an entirely new polygonal feature class with attributes that represents the intersection of all of the features in the inputs. Now, which approach you use depends on your ultimate product that you're trying to generate. I like to use query where I can because it doesn't create any new data, but occasionally, for example, I need to create new features that represent the intersection and calculate that area. In that case, I'm going to use analysis. Overlay analysis allows us to analyze relationships between overlapping features. It allows us to answer the question, what's on top of what? Like, what soil type is under the proposed road? Or how much of the site is wetlands? Or how many people live in selected zip codes? Or what is the median income in the service area? Generally, these overlay relationships can be categorized as clip, erase, combine, and aggregate. And we'll talk about each of these. And you can find most of these geoprocessing tools in the geoprocessing analysis toolbox under the extract, overlay, and statistics toolset. But don't limit yourself just to these tool sets, because overlay geoprocessing tools are sprinkled throughout all of the toolboxes in ArcGIS Pro. First, let's talk about geoprocessing tools in which the output represents a clip of the inputs. And we'll start with the clip geoprocessing tool, which is pretty straightforward. It allows us to extract input features, in which the input features are those features to be clipped, and the clipped features is the cookie cutter that we're going to use for the clipping. And you can see that illustrated on the diagram in the right, in which we have input features that include, for example, rivers and land and maybe some locations of something, and the clip feature, which is the yellow polygon. And the output includes only those features that are within the extent of the clip feature. This is really handy when you're starting out a project and you're assimilating a bunch of data from a bunch of different sources that has a lot of different extents, and you want to clip it down, for example, to your project extent. So I'll use the clip feature to get everything clipped to the area of interest for my particular project. A version of the clip tool is called the split geoprocessing tool, in which we extract input features to multiple feature classes. In this case, the input features are those to be split. The split features are the features that will be used for clipping, and the split field will identify the unique zones in the output. The difference being that there's not just one output, there's multiple outputs, one for each zone that is identified by the split field. And you can see in the diagram on the right, again, I have the inputs. In this case, the split feature includes multiple zones that are identified by the split field. that include multiple outputs. And I can imagine using something like the split feature if I was doing a search and rescue and I had gridded out an area and I wanted to create compact data sets that I could load on mobile devices for my search and rescue crews. A couple of other geoprocessing tools that clip the output include intersect and identity. We use intersect to extract overlapping features and attributes. The input features are those to be intersected, and the attributes to join are the attributes you identify that will be included in the output. And you can see in the diagram on the right, I've got my intersecting features, and then I've got my output, which outputs only the intersecting geometry along with the attributes that you've selected in attributes to join. Identity allows us to extract only input features and overlapping identity features. In this case, the input and identity features are those to be intersected. And again, the attributes to join in the output are those attributes that will show up in the output. But the difference between intersect and identity is that the output includes all of the input and then the intersecting portion of the identity feature. Another type of overlay relationship that we utilize for vector overlay analysis includes erase, where we erase overlapping features. And again, there's a tool called erase that we can use to clip and delete the input features. And so the input features are those to be clipped or deleted, and the erase features are the features that will be used to clip and delete. It's the cookie cutter again. But in this case, the output is not the inside of the cookie cutter, it's the outside. And if you look at the diagram on the right, you can see my input layer minus my erase feature includes my output layer. I can imagine utilizing a tool like this if I was doing future development scenarios. And so I wanted to clip out the current area and then generate different scenarios that I would plug in to the portion that was erased in my output. Another geoprocessing tool in which we erase overlapping features is symmetrical difference. We use symmetrical difference to clip and delete overlapping input features. The input features, again, are those to be clipped and deleted. The update features will also be clipped and deleted, and then you'll identify the attributes to join in the output. And you can see in the diagram on the right, I've got my input layers, and the output represents only those features that do not overlap or intersect in the symmetrical difference output. There are also vector overlay analysis geoprocessing tools that we use to combine overlapping and non-overlapping features and attributes. And the most common version is union, in which we combine the input features and attributes. And so the input features are all the layers to be combined. And then we also include the attributes to join in the output. And there you can see in the diagram on the right, I've got my input features, and the output includes the intersection of everything, both the features and the attributes that I've selected. Update is a version of union in which we combine the input features and attributes with the update features only. So it includes the input features and attributes to be combined with only the update features and not the update feature attributes. If you look at the diagram on the right, you can see that I've got my input features and my update features. And in the output, my update features are burned into my input to create a new set of features from both layers with the attributes only from the input layer. The last category of vector overlay analysis I want to discuss is aggregate, where we join overlapping features and summarize attributes. And the most useful of these tools is probably spatial join, which we use to append join attributes to target features and attributes. Now, a lot of times I'm working in GIS and I'm trying to establish a cardinal relationship between two layers and its associated attributes, and I just do not have any attributes that I can utilize to create a join, for example, or a relate. But my layers have a spatial relationship. So in that case, if they don't have a cardinal relationship but a spatial relationship, then you use spatial join. And you'll set your target features and attributes that'll show up in the output, and then the join features, which are the attributes that will be joined to the target features. And you can see in the diagram on the right, I've got the target layer, which includes two blue rectangles with the IDs 1 and 2, and the join features, which is a yellow circle, which in this diagram is assigned the attribute value A. And if you look at the output, you can see it only includes the geometry from the target features, but it includes the attributes from both. So the output includes the two rectangles from the target, but the attributes from both the target and the join features. In this case, 1 and A and 2 and A. Another vector overlay analysis aggregation tool is aggregate points, which we use to aggregate points and summary attributes into polygons or bins. In this tool, the point layer is the thing to be aggregated. So we're aggregating points and attributes associated with a point layer, and then the polygons or bins in which the point layers will be aggregated into, along with any summary fields and their statistics. And if you look at the diagram on the right, you can see that it includes polygons or bins, in this case, bins that are represented as flat-topped hexagons. And then the points within the bins are aggregated into the output that includes the bin along with the summary field and statistics for the points. So if you look at the bin in the upper right-hand corner, you can see that it includes the points with values 9, 9, and 8. And so the output in this case included the sum of that field and their values, which is 26. Using aggregate points to create polygons or bins with summary statistics is really a great tool if you have really large point data sets, but you want to look at overall trends within that data without getting lost in the individual data points themselves. So we use this to aggregate those points into polygons or bins and then analyze those generalized trends in the data. Another vector overlay analysis aggregation tool is InRich. We use InRich to aggregate summary attributes into features. This is a new cloud-based geoprocessing tool in which ArcGIS Pro works with ArcGIS Online. Often you have your input features, which might include polygons or bins in ArcGIS Pro, and then you want to populate it with different types of attributes that are readily available in ArcGIS Online. You can use InRich to do that. And so you go in, you select your input features, and then your variable to be aggregated within the input features. And the list that you see in the diagram on the right are just a few of the types of variables that are available, for example, like education, business, and race. And then you can aggregate the underlying data within your polygon or bin with summarized statistics. And you can see the output includes my input features, but also the aggregated and summarized attributes for the variables I've selected. We've talked about clustering, in which we can take multiple points and aggregate them into summarized points. And we actually use that functionality in ArcGIS Online. ArcGIS Pro is not as far along as ArcGIS Online when it comes to clustering points. There are a few tools that you can utilize. One of them is the 80-20 analysis. We can use to summarize points and attributes into clustered points. And so we set the input points as those to be aggregated and also select the output fields, along with a few other parameters that control how much aggregation happens. And there you can see I've got 23 input points and my output, which includes 6 clustered points that represent the attributes and statistics from the input points.